This is the Magnetic Levitator project by Bohn, Thomas Benson, Edwin Chiuz, Josh Hampton, and Chris Parrish. The equipment we used was a 12 volt DC 180 Newton electromagnet with a 49E linear Hall effect sensor. Our power supply was a Lenovo laptop power supply that output 20 volts and 2.5 amps, which was stepped down by our resistors, which created a voltage divider to step it down to 12 volts for our electromagnet. Our system was controlled by an Arduino Uno with a IN4001 diode for the overcurrent of the electromagnet. We used a 8A25RL enhancement MOSFET for the control of the electromagnet and two 10K potentiometers to control KP and KD. The base was 3D printed, and here we describe how our power supply was stepped down with the general equation for the voltage divider and the specific values that we used to step it down from 20 volts to 12 volts. Our root locus diagram shows our choice to use the PD controller, which allows us to overtune the gain and slowly move it down to a more stable system. But the ideal operating point for our system is 45 degrees from the real axis, as shown by the squares marked on the graph, and that would give us the best response time for our system. Here's our circuit diagram of the system. You can see the sensor reading into the Arduino with the analog or the digital output outputting to the MOSFET controlling the solenoid. And on analog 3 and 4 and 5 volts, we have the two 10K potentiometers controlling the coefficients of KP and KD. Some of the obstacles we initially encountered while working on this was finding the correct sensors, where we found multiple Hall effect switch sensors which do not work. They have to be linear Hall sensors. Otherwise it just gives you a digital value of 0 or 1. The 3D printing of our housing caused some difficulties with incorrect prints or prints being removed, but was generally not too much of an issue. And the power supply, setting that up, was somewhat difficult, getting it to output voltage while it was completely cut open. But by grounding the grounding wires around the center power line, we were able to have it output and not stop any voltage output from the laptop charger. Here's our Arduino code. We realize that it is lacking the transfer functions for a feedback system, but still includes KD and KP that is read in from the pins, analog 3 and analog 4. Tau D is also calculated immediately after, and dy over m from our curve from the magnet mounted on the levitated object and the sensor has been determined and is also in there with the set point value. Here's our fully constructed levitator. Here's our 3D printed arm and base / container here. Here is our moving levitated object, and it is just a nut with a small neodymium magnet on the top. On our board we have the voltage divider circuit, which is these resistors here, and the diode right here, which is protecting the rest of our circuit from the inductive nature of solenoids. And powering it outside of here is the laptop power supply, which gets fed into that voltage divider circuit that I was talking about. And here is our MOSFET that controls the current of the system using the Arduino's digital output. Here's the digital output for the Arduino coming out from the 5, digital output 5, and here's the Arduino reading in the sensor analog system.